Hello everyone. Hope you are safe and sound. In our previous session, we learned occurrence of metals. In this session, we will learn refining of metals. The metals produced by various reduction processes which we learned before that all metals are not very pure. They contain some impurities which must be removed to get pure metals. The most widely used method for refining impure metals is electrolytic refining. So, this is the method for removing impurities, and that process is called electrolytic refining. So, now we will learn about electrolytic refining process. Many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically, which means these all metals are refined by electrolytic refining. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. So, here also in the figure you see anode, that is positive road, and what will be anode here? The impure metal. Okay, and what will be cathode? It is the rod which will be thin strip of pure metal. A solution of the metal salt is used as an electrolyte. We have learned in standard 8 what is electrolyte. Okay, it is the solution from which the electricity is passed, and this solution is used for this electrolytic refining. So, what to take as electrolyte? A solution of the metal salt. The apparatus is need to be set up as shown in the figure. What will happen? When the current will be passed through this electrolyte, the pure metal from the anode dissolves in the electrolyte. Okay, what we have taken as anode, we have taken as the impure metal. So from that anode, the pure metal will be dissolved in the electrolyte. At the same time, an equivalent amount of pure metal from the electrolyte is deposited on the cathode. So now the pure metal which is there in the electrolyte, that will be deposited on cathode. The soluble impurities go into the solution. Now we have already taken anode as impure metal, that means there will be impurities. So the impurities which are soluble, which means which can be dissolved in the water, that will go in the solution, and the impurities which are insoluble, which cannot be dissolved, that type of impurities will settle down at the bottom of the anode and are known as anode mud. You can see in the figure there are impurities at the bottom part of anode which is shown as impurities, which is called anode mud. So this is the whole process of electrolytic refining. Now let us learn this electrolytic refining by taking an example. Here for anode, which is positive terminal, which is positive road, that is taken as impure copper. Here we are learning about copper. So anode will be impure copper, and as a cathode, negative road, that will be pure copper. Now, what to take for cathode? A thin strip of pure metal. So, as cathode, we will take pure copper strip, thin strip. Okay. Then, what to take as solution? Electrolyte. So, here we'll take copper sulfate solution as electrolyte. Now, when the electricity is passed, what will happen? On passing the electric current through this electrolyte, we will observe that the pure copper from anode will be dissolved in the electrolyte, and that same amount of pure copper from the electrolyte, that is the solution, will deposited on the cathode. In the figure also it is clearly shown. Okay, so what will happen? In short, we have to remember that on passing the electric current, the pure copper will be deposited at the cathode. Okay, now the soluble impurities will go into the solution, copper sulfate solution, and the impurities which are not soluble, which are insoluble, they will settle down at the bottom of the anode. In the figure we can clearly see it is called anode mud, the impurities which are insoluble. So as a result, this way we will see that the pure copper is deposited at the cathode. So this is an example of refining of copper. So this is all about refining of metals, in which we learned electrolytic refining.